we'll be okay. We are going to spend another day tomorrow just practicing all of this. So keep that in mind. So what we talked about on Monday is I said there's 3 things that have to be true if a radical is in simplest form. There can be no perfect square factors under the radical sign. That's what we've been working on fixing. That's what you do the cake method, or look for those perfect square factors and divide them out. Okay. Now the other 2 we haven't talked about yet. Okay. But the second one is pretty simple. So the second one says you cannot have any fractions under the radical sign. That's a pretty easy problem to fix, you guys will see. But this last one is the one that gets a little tricky because you cannot have any radicals in the denominator. You can have in the numerator, no problem there, but you cannot have a radical in the denominator. So let's talk first about if you have a fraction under the radical sign. So, for example, let's say I have the square root of 49 over 4. So this is not in simplest form for the big glaring reason you cannot have a fraction under the radical. Just can't do it, okay? This is a super easy problem to fix. If you have the square root of a fraction, what you can do is you can break this apart and take the square root of the numerator over the square root of the denominator. That's an easy problem to fix. So if you have a fraction under a radical sign, just break it up into 2 separate fractions. That's an easy problem to fix. Now, we also cannot have any perfect square factors under the radical, so this is where you would, okay, we'd have to cake 49, we'd have to cake 4, or find the square root of 49 and the square root of 4, okay, which in this case it kind of works out fine. But that third rule, there cannot be any radicals in the denominator. For this one, it works out nicely. I cannot have that square root of 4 in the denominator, but the square root of 4 is 2, so it goes away anyway. And the square root of 49 is 7. So sometimes today, it's going to work out nicely where, okay, the radical in the denominator that can't be there, it goes away because it's a perfect square. Now, sometimes I'm going to end up with a radical in the denominator that's not a perfect square. What we're going to have to do is we're going to have to do what's called rationalize the denominator. So I want to look through an example as we talk through these steps. So we're going to do 6 over the square root of 5. Now if we kind of go through our steps, our checklist, number 1, you cannot have any perfect square factors under the radical. So I only have one radical here, it's the square root of 5. And the square root of 5, if you try to cake 5 or look for perfect square factors of 5, you're not going to get anywhere. The square root of 5, just square root of 5. So there's no problem there. There are no fractions under the radical, right? I don't have like this big fraction here, so that's not a problem. But I have this radical in the denominator. You cannot have a radical in the denominator. So the first thing we want to do, and this step is kind of optional in a way, but I promise you it makes things easier. The first thing you want to do is you want to simplify. Simplify as a fraction and look for perfect squares if there are any. What I mean by simplify, if you had a fraction like 2 over 4, you know you could reduce that into 1 over 2. You want to do that if you can. But how we talked about yesterday, how you can multiply numbers outside with numbers outside, and you can multiply numbers inside with inside, it's the same thing when you're simplifying. Okay? So if you have a fraction, you can simplify numbers as a fraction that are in the same place. So for example here, the 6 is outside and the 5 is inside. If they had something in common, which they don't, you wouldn't be able to simplify them anyway. Because one's outside and one is inside. But if you can, sometimes that makes your job a little easier. Okay? Now, I can't do any simplifying, so here's how you're actually going to rationalize the denominator. You're going to multiply the numerator and the denominator by the radical that's in the denominator. So the radical that's in the denominator is the square root of 5. So what I'm going to do is I'm going to multiply the numerator and the denominator by the square root of 5. Now let's talk about why first of all. We'll see what happens here, why I'm doing this. But the reason why I have to multiply the numerator and the denominator is because if I just multiply the denominator, I'm changing the number. Because I'd be multiplying by 1 over the square root of 5. And if you multiply something by 1 over the square root of 5, it's not going to be the same number. It's going to change the number. But if I multiply by the square root of 5 over the square root of 5, think about this. What's 5 over 5? 1. And if I multiply by 1, it doesn't change the number. Right? Okay, so if I multiply by the square root of 5 over the square root of 5, what is the square root of 5 over the square root of 5? It's also 1. It's also 1, right? Because 5 over 5 is 1. 10 over 10 is 1. 1,000 over 1,000 is 1. The square root of 5 over the square root of 5, it's just 1. So what I'm doing here is I'm multiplying by 1. And when I multiply by 1, it doesn't change the number. Okay? So that's why you have to multiply the numerator and the denominator. Now, here's why we want to multiply by the square root of 5. Look what happens here in the denominator. We learned yesterday that if the numbers are in the same place, you can multiply them together. So I can multiply the 5s, and I get 25. But they have to stay under the radical. What's the square root of 25? 5. So when you take the square root of 5 times the square root of 5, I now just have 5. See how my radical's gone in the denominator? Okay. Now in the numerator, the 6 is outside, the 5 is inside. So you can't multiply them together and make them 30. The 6 just has to stay outside and the 5 just has to stay inside. And then the last thing you want to do is make sure that you can't simplify at all. So simplifying involves seeing if you can simplify the radical, but we've kind of already ruled out that you can't simplify the square root of 5, it's just the square root of 5. But you also need to check and see if you can simplify as a fraction. Remember what we talked about at the very beginning, that if you're going to simplify as a fraction, the numbers have to be in the same place. So I do have a 5 in the numerator and the 5 in the denominator. But in the numerator, that's technically not a 5. What is it? What is it? It's not a 5. It's the square root of 5. 5 and square root of 5, not the same thing. That 5's inside, that 5's outside. You cannot simplify those if they're not in the same place. So for this one, that would be your answer there. Okay? All right, let's get this glued into page 57. This is our last section of, or our last day of 10.2, and it is dividing radicals. Okay, so I'm going to kind of take you through just my process, how I work through these. Just know that with a lot of these, you may go a different path for how to get to your answer, and you can still get the right answer. You guys know me by now, hopefully. I'm like a consistency person. I like steps and procedures. I know a lot of times in math, we can't always say, okay, do this first, and then do this first, and then do this. Whenever possible, those are the kind of things that I like to do that, kind of at least a checklist. So that's kind of how I approach these. There may be an easier, quicker way to get to the answer, but I kind of like to do, okay, let's try this first, and then this, and then this, and it's not really a one-size-fits-all thing, but it's the best that I could come up with. So, like I said, you may see a different way to go about getting your answer, but this is just what I do, okay? So, number one, let's say we have the square root of 81 over 4. So, with these ones, the first thing I do, if I ever see something like this, I know for a fact, for certain, I cannot have a fraction under the radical sign. And that's a really easy problem to fix, because all you do is take the square root of the numerator over the square root of the denominator. That's the first thing I do. That's the easiest problem to fix. Now, the next thing that I'm going to encourage you, and it's not necessarily in the steps, look for perfect squares. If you see perfect squares, man, jump on them. And here, right, are both of these perfect squares? Yeah, square root of 81 is 9, square root of 4 is 2. If you see perfect squares, those always take priority over any other step that I tell you. So, in this case, 9 over 2, that's it. That's all you got to do. Sometimes these can be either made a lot more difficult or a lot harder, depending on right? What you're kind of looking for. Okay, number 1, the square root of 60 over 49. Now, kind of like the last one, the first thing I do, like I said, not the only way to do these, but the easiest problem to fix here, I cannot have that fraction under the radical sign. So instead, I'm going to break it apart and do the square root of 60 over the square root of 49. Now, like I said, all the time, like each step of the way, you should be seeing, okay, do I have any perfect squares? I do, right? That denominator, which is actually the best place to have a perfect square, because we can't have that fraction, that radical in the denominator. So that problem is fixed, but I have the square root of 60 in my numerator. The square root of 60 is not going to be simplest form. You have to cake it, or look for your perfect square factors. Either way, the square root of 60, it's a number under the radical. That's how you're going to know if you should try to cake it. If it's a number under the radical, you need to see if you can cake it. So out of 60, I could divide out of 2, I'd get 30. Divide out another 2, I'd get 15. Divide out of 3, I'd get 5. Divide out of 5, I'd get my 1. So I have a pair of 2's. So the square root of 60 that was in my numerator now turns into a 2 on the outside. And I'm left with a 5 and a 3 on the inside. So remember, those are going to be multiplied together. So 5 times 3, we're going to be left with a 15 on the inside. Now, the last thing you do before you circle a box your answer to move on to the next problem, you need to make sure it's in simplest form, fraction-wise. Okay? So remember, you can only simplify, multiply, divide numbers that are in the same place. So the 15's inside, nothing else is inside. Okay, so you can't do anything with 15. But if the 2 and the 7 had something in common, you'd want to reduce them. They don't. So that would be your answer there. Okay, number 3. Let's say we have the square root of 81 over 9x to the 4th. Okay, once again, just my personal preference, the easiest problem to fix out of the 3 checklist items. I can't have that fraction under the radical, so let's do the square root of 81 over the square root of 9x to the 4th. And then at the same time, always looking for those perfect squares. Do we see some perfect squares here? Right? Both of them, actually. Right? The square root of 81 is 9. Now, on the bottom of the radical, or the bottom of my fraction, I can take the square root of 9 and get 3. And I also have an x to the 4th under the radical. Remember, with the variables, you're pairing them up. How many pairs can you make out of x to the 4th? 2. Now, before you circle and box your answer, move on to the next problem, you need to make sure it's in simplest form. The radicals are gone. This is just a fraction. If you had 9 over 3, would you leave it as 9 over 3? I hope not, right? What can you divide out of 9 and 3? A 3. Now, be careful here, because when I divide out by 3, 9 divided by 3 is 3. The 3 divided by 3, they're gone. But that x squared, it's still in the denominator, okay? That x squared doesn't flip sides of the fraction. It's going to stay there in the denominator. Okay, number 4. Okay, let's say we have the square root of 60 over 27. Okay, once again, what I'm going to do first, let's get rid of the fraction under the radical. So we've got the square root of 60 over the square root of 27. Remember, we always want to be on the lookout for perfect squares. Are either one of these perfect squares? No. This is kind of where you could go 2 different paths. Here's what I would do. And guys, I almost guarantee you it's going to be easier than what the alternative would be. Simplify if you can first. Simplify as a fraction. So you have a 60 under the radical in the numerator. You have a 27 under the radical in the denominator. They're both under the radical. So if you were to treat this like a fraction, could you simplify 60 over 27? What do they both have in common? 4. 3. Since they're both under the radical, just like you can multiply numbers under the radical, you can divide each of these by 3. You can simplify these. Now, when you do that, they still stay under the radical, but at any rate, at least they're smaller numbers. But actually, in fact, what do you see now? See the perfect square? Okay, the square root of 9 is 3, which, guys, what we're going to find out is that's beautiful because I no longer have a radical in my denominator, which is the biggest problem to fix, okay? Now, I'm not going to leave the square root of 20 as the square root of 20. What would I need to do? We need to simplify the square root of 20, so we need to take the square root of 20, or what perfect square goes into 20? 4. 4 times 5. The square root of 4 is 2. I can't take the square root of 5, so it stays the square root of 5. You want to make sure that you can't simplify anything. The 5's inside, so it couldn't be reduced with anything, but the 2 and the 3, they don't have anything in common. If they did, you could reduce them, but they don't. Okay, number 5. Now let's say we have 4 over the square root of 5. Okay, so if we kind of go through the process, I don't have a fraction to break up. I can't reduce it all because the 4's outside, the 5's inside. They don't have anything in common anyway. The only problem here is I have that radical in the denominator. Here's how you fix that. You are going to multiply the numerator and the denominator by the radical you are trying to get rid of. So in the numerator, the 4 is outside, the 5's inside. The 4 has to stay outside, the 5 has to stay inside. You can't multiply those together. But in the denominator, we're going to show this step one more time, but after this step, we're going to go ahead and skip this step. The 5's are both inside. You can multiply those together, but they have to stay inside. And the square root of 25, 5. Guys, when this happens, when you take the square root of 5 from the square root of 5, you are going to have a pair of 5's under the radical, which just like in your cake, becomes 1 5 on the outside of your radical. Okay, and the last thing you want to do is make sure you can't simplify. I see that I have a 5 in the numerator and a 5 in the denominator. Yeah, but that's inside and that's outside, so nothing you could do to simplify there. Okay. Okay, number 6. Let's say we have 15 over the square root of 10. Once again, break apart the fraction if you have one. I don't have a radical under my fraction, so no problem there. I want to simplify if I can. Now, 15 and 10, they both have a 5 in common, but the 10's inside, the 15's outside, so I wouldn't be able to do that. So we're ready to do what we did in the last step. We're going to multiply the numerator and the denominator by the square root of 10. Like in the last one, the 15 is outside, the 10 is inside, so the 15 has to stay outside, the 10 has to stay inside. Now, in my denominator, I have the square root of 10 times the square root of 10. Remember what happens here, there'd be the square root of 100, the square root of 100 is 10. Guys, you can skip this step right here. The square root of 10 times the square root of 10, so it's going to be 10. Square root of 5 times the square root of 5, always going to give you 5. Okay? Now, this time, I have a 10 and a 10, but that 10 inside, that 10 is outside. But you see the 15 and the 10? The 15 and the 10, they're both outside. So I could divide each of those by 5, and we get 3